I think it has started. Okay, yeah, the streaming has started. Good. So, okay, so I'll use this as my. Okay, streaming has started now. Good. Yeah, I'll mail in that group. Okay. So live streaming has started. Okay. Can you see my? Yeah. Sorry. Sorry, there was some issue. Because there was some problem. Okay, I think it's now on. Fine. I'll just. There was some connection issue. I'm really sorry for that. Okay. Yeah. Okay. Okay. So yeah, sorry for the delay. I'll start presenting the screen. Is the screen visible now? I hope it's visible. So I'll start without delaying further because we have already got some delay due to the connection issue. So okay, so the first question was what does H227993 works? So I use yeah. So the before proceeding, what I was saying that I use Python interpreter uh, as my uh, for writing codes and all because Spider I feel it's very uh, user friendly and easy to use for everyone. uh, yeah, so the thing that how you do is like this. Okay, so this code, how it runs right? Someone's mic is on, can you please turn it off? Audio issues, are you not, is it not audible? Okay. Now is it audible? Hello, now I'm audible.
Yes.
Okay, good. Okay. Yeah. So can everyone turn off their mic, please? Please, some background is coming. Okay. So the first I'll just tell you how to do this, how to um, install this thing. So for that, I will show you 1 second. Yeah. So I think you can see the video. So for installing Spider, just go to just type Anaconda in the in your web browser. Type Anaconda. YouTubers cannot see, I think. Yeah. So just type Anaconda here and you'll see that Anaconda. Then if you just download Anaconda, it's for Windows, so exe file will download, and if you install, automatically the all the files and everything will come. Okay, you don't have to do anything else. Spider will be automatically installed and you have to just open Spider. Okay, so that's how you do it. If you need anything, please just give me a message or mail. I can share you some videos where you can just check. Okay, this is very annoying. So now I'll again start sharing the Spider. Hello, yeah. So this is how this is the user environment. So this is here where you write your code, and this is your console. So in console, if you write anything, say I say print my name is Shobik, it will show. So print my name is Shobik and it will print it. See, my name is Shobik. If you want to do something, say 3 plus 4 7 3 to the power 3 square. So to the power is given as double star here. So this here you can use as our console. Okay, and this part where you write the code. So this is how the code is. So what does first the code does is, uh, so it takes a number as input, is this function number as input, it, and then dn at the start of the before the start of the loop, the d is 1 and n is 0. Okay, so while d is less than equal to x, d will be multiplied into uh, 3. Okay, so each time this loop runs, the d will be now multiplied into 3 and n will go for 1. Okay, so till then d is less than x, rather this d is less than 27933, the function will run and it will say it took how many times or how many loops to go till it goes greater than x. Okay, so there is another beautiful uh, options of in Spider, that is known as debugging. It's not a specific for Python, but it's not a specific for Spider. You can use the same debugging in PyCharm and many other Python interpreter also. So debugging actually what causes. So sometimes say you have got a mistake in the, so you have done some mistake in the code, so you are not getting the particular output you want. but there are no visible error in the console, because if there was any visible error, say a flight CV is equal to something, I have not closed it, or say I have not closed uh, the the inverted commas, it will show something, some issue is there, but there is maybe some error which you don't see here, but you want to but you don't know where the error is coming. So that time you use something known as debug. So debugging, what this does is it creates a breakpoint. So you can give a breakpoint like this, just you will see the red lines here, and you can now you can so the code will now run and stop until here. Okay, now we can see what is happening inside the code. So there is this options called debug file. You can see the control F5 or debug, and see the code now has stopped here. So this is the line, you can see the arrow mark here. So the notes code will stop here, and you can see to how the code works. Okay, so if I before starting it, I will just run the code here. So if I just run it, it H2293 is 10. So how the 10 is arrived, that I will show you by debugging. Okay, so this is first one at first, and you can change how in the variable explorer, if explorers, you can see how the variables are changing while the code is running. Okay, sorry, I couldn't. Yeah, YouTube, I cannot see all the comments or everything, because it's not possible for me to see in both places.
Sir,
Right. Yeah.
can you zoom your screen, sir?
Okay,
It's not visible clearly, sir.
yeah, because I think you have joined with your mobile, that's why I think it's not visible.
It's we are logged in my laptop.
Okay,
Laptop.
how to, okay, I'll is now it is clear, it's better.
Yes, sir.
Okay, so I just did a control plus to increase the font. I think now it will be better. Yeah, I have sent already a mail for the YouTube link in the group, in the discussion group. You can go and check there. I hope there will be no issue there. You can see the messages there, and comments, sorry, I cannot see there, because it's not possible for me to see the comments there. So if you have any issue, you can keep the comments, I can do show it later. Okay, so debugging, yeah, I was in debugging. So at first you can see, if I execute this line, so by this line you go to execute this line and go to next line. So this is the uh, option for that. So first you can see d is 1, n is 0. Now while d is less than equal to x, what is our x? X equal to 27933. We proceed. Then this step, if we run, it becomes d becomes 3, because 3 into 1 is 3, and n equal to n plus 1, because one time the loop ran. Second step, if I go again, it will run, again it will run. So I'll give another breakpoint here, and here this is the for the first forwarding. So if you continue the code till the next breakpoint comes. Okay, so you can see the each time the d is getting multiplied into 3, and it's getting nearer to the x. Okay, so if I now go, it will, after 10 steps it will go. So if I now do a just first forwarding, see now after 10th step, now at the 10th step, now d into 3 has become 59049, which is more than 27933, and n is equal to 10. So n, it will function will return 10 n, and so the function is returning it's just nothing. Just stop it here, stop the debugging, because this one, yeah. So now the function is returning n, and if I debug it once more, and it's returned 10. Okay, so I have printed the code. I think so how to write the function and those things, I think they will solve, sir will teach you in the sorry, week 2. So we'll move on to the next question, this one. Yeah, so the correct answer here will be 10, and we'll move to the next one. Okay, and what does this
Excuse
function?
me, sir.
Yes,
Sir,
yes,
sir, in the assignment we have to type answer only, sir.
yes, you have to just type 10,
Okay,
and
okay.
just
Thank
you
you,
have to
sir.
type 10.
Thank you, sir.
Yeah, okay. uh, okay, in the next one, there is another function with this g. So g60, so this function again also takes a value, a number, and does something inside the function. So to make you little more clear, before I go directly to g, so I'll define two variables. G60 is equal to g, I'll call the function g60. This are g60 is defined under, but it's just a variable. I want to make sure if I make you clear, so that, so I'll write again a code. G48 is equal to g of 48. So by this is how you call the function. So this is a g here. G is the function, and if you type if you just type here g and give so it will show you, so it takes as a n as your number. So if you just type, say, G3060 or G65, like that will work. Okay. So how does this function work? Let's see. So yeah, so this function, at first s is equal to 0, and for I in range of 2 to n, so I is going from 2 to n minus 1, basically, because 2 to n means, as you may know, that in Python, if you type, say, uh, for I in range 1 to 10, it will type till 9. So see, 1 2 3 4 5 7 8 9. So in Python, every range goes from I, whatever. If you want to uh, do a ranging, it goes from, if you want to have a range of m to n, you have to write in Python, you have to write m to n plus 1. Okay, so in Pythonic language, you write it uh, range of m comma n plus 1. Okay, n plus 1, and by default the increase is uh, increases by number of value of 1. But if you want, uh, you can keep it like 2 3. You cannot write 2.5 or 3.5, because it takes only in integers. Okay, so if I write, say, range of 1 to 10, so if I need from 1 to 10, so I have to write 10 plus 1, that is 11. And if, say, I want all the odd numbers till 10, so I'll write 2 here, because then the range will go. And if I print it now, see, 1 3 5 7 9. Okay, so first argument will be the start of the range. Second argument will be the end of the range plus 1, and this third argument should be the how much step jumps you want to do. By default, it is 1. Okay, so yeah, so now if I go here, so for I in range of 2 comma, if n, okay, yeah, I think we came back, right? Is it visible now, and am I audible? Yeah, Am I audible now? I think it's visible now the screen, so I'll start again. And okay, thank you. Sorry for the interruptions. Okay, really sorry. Okay. Um, so we are in the second quiz, right? So here the code runs like this. So if so one at the start of the code s is equal to 0, and for I in range of 2 to n, if n divisible by I, s equal to s plus 1. Okay. uh so how do you use this now? So how the code runs is like this. So if for I in range of 2 to n, if anything is uh, n by I, so whatever 2 to n, whatever things are divisible by n, so it will be s added to the uh, so s will be added to plus 1. Okay. So if I debug it again, and I'll show like this to you. If I debug it again and I'll show this to you. So as sorry. So if I debug this, so first s is equal to 0. If you run it again, so first I will be 2, because I is 2, and n by I will be 2 by 60, that will be equal to 30. So s will be s plus 1. So first, so s has like s option will go, then next it will go up to 3. 3 is also divisible by 60 is also divisible by 3. So yes, again this uh, condition satisfies. So again s will be plus 1. Then again it will go, and this 4 is 60 is also divisible by 4, so it will go. 5 is also divisible by 6, so 60 is also divisible by 5, so s plus 1, and s is then 4. Okay, 6 is will be also when, but 7 comes, 7 is not divisible, so 7, so s will be not s plus 1, so s will move. If this condition does not satisfy, so it's not the way. Again for 8 also similarly, it doesn't satisfy, correct? So for from the first function, if we run this, we'll get the G60, correct? And if we run it till the last next breakpoint, so what is our G60 was now is 10. Okay, so 10 numbers are basically in that from 2 to 60, 10 number is divisible by 60 is divisible by 10 numbers. If we do the same for 48, see 2, 3, 3 is it's not 3 is also 3 is also can divide 48. So after 4 also can, but 5 cannot. 4. So now this is look at this. This is 5. So 5 can be is divisible. So it's not divisible. So 5. So 5 cannot be divisible. So like that it will go, and it will give us 2. So only so yeah, so G48 would be 8. So then G60 minus G48 would be 2. Okay. So this is how this code works. So by the way, here you can define a cell. So by default defining cell, you do like this. You press the hash and press 2 percentage sign, so this will create another cell. Here you have an option of running just a cell. So if I just run this cell, it will give me the option 2. Okay. Okay, then next one. Yeah, this is a good one. So what were the options here? So the options, we had these options here. So these are the options. Okay, so what does this function? So this is again a function that takes number as its as a argument, and if n gives a true for a returns true for a positive number n if and only if one of these will be our option, correct? So how this function works? So this if n at the first, so if I just give f of say 6, okay, so how this function works, I pause it, and yeah, so at first s is equal to 0. Oh no, this I think, sorry, this function to debug cell here. So yeah, we'll debug this cell. So the option is this. So if at first s is equal to 0, okay, and so you can see that n is equal to 6 and x is equal to 0. So and so the function will run from 1 to n plus 1. So if n if I do divide I, the remainder should be 0 and the divisor should be I. Okay, so n by I is equal to I and s equal to 1. So 6 by 1, the divisor though is equal to 0, but 6 by 1 is 6. So it should, if it would have been 1, then only it would have uh, been possible. So now if it is 1, it is not. So so n by I is 6. Okay, so I is 1 and it's not true because if it should have been 1, correct? So it is not true. Then next one, again if it is true, but n, again if I just do n divided by I, it is 3, so it is not equal to I, or I just say equals to I, it would say false, correct? If we move like this, so none of it will be actually true. So if you see, any of it doesn't go to s equal to 1. So it will return me a, it will just return false, correct? As if I run this cell, to return me false, because s is never 1, s is always 0. So if s is always 0, so 0 divisible by 2 is always 0. So 0, if I divide by 2, is always 0. So it will always come as 0, it will never. But if I do 1 by 2, it will give 1. So only 1. Now there is a simple mathematics here. So if you just consider this particular argument, so this particular argument says that so one thing, if we are observing, I'm doing a commenting here. So if you anything want to do commenting, do this triple inverted commas, and in between this everything will not be executed. Okay, this is how you comment something. And also you can do one more thing, for one line commenting you can just use hash. Whatever you write after hash, it won't be executed. Use just comment. So n this by I is equal to I, correct? And since n by I is equal to 0, that means from there we can also say that n divides I equal to I. Okay, now we consider this, n by I is equal to I. So if I move the I to here, n is equal to I square, correct? I into I. Or if I next time I can say that I equals to n to the power half. Now if n is an odd number, so this n is a, so n is a positive integer, correct? Positive integer. So if n is an odd number, say 3 by so n to the power half, n is a positive integer, as well as, sorry, as well as, because I is just in a range, so it has to be a positive integer also, as well as I also a positive integer. So integer, so like if, so I cannot be 1.5, right? So if I say for I in, say, in range of say 1.5 to 3 and print I, it will give me an error because I is always a positive integer. See, float object cannot be interpreted as integer, so I should be always a integer. Okay, so for I is, I should be also a positive integer as well, I also. So if I has to be a positive integer, then n to the n, square root of n to the power half or square root of n cannot be anything, cannot be just only a odd number, which cannot be odd number at all. So it can be odd number, but some odd number, because 3 to the power half is not an integer, but 9 to the power half is an integer. Okay, if it's a prime number, that also cannot be true, because prime numbers to the square root of a prime number will never be an integer. Can it be a perfect square? Yes, if it's a perfect square, then only all the time. So we can write if as a perfect square, so we can write that I is equal to n, rather m square, m square, which will be m is a perfect square, n is m square to the power 1 by 2. Then only we can get the, so n is equal to l, where n is equal to m square. Okay, so then only we can get a positive number. So n should be always a perfect square number, and so this is the correct option. N is a perfect square number. This is the correct option, option 3. Okay, and now I'll move to the last question of the day. So consider the following function. Foo. Okay, already. No. So this is another function here, and so this is something known as recursive function, because inside the function, you are again calling foo m minus 1. Okay, so each time you are calling the function, you will go to m minus 1. So till m minus 1, till m is equal to 0, it will call the foo function inside it. So when the function is running first time, say I debug the code, then we'll debug cell. So foo of 5 I am doing. Okay, here. So first time when I am doing, m is equals to 0, m is not equal to 0 because m is 5. I can say that m is, what is m is 5. Sorry, so m is 5, so the return will not be 0, else return m of foo of n minus 1. So m of m plus foo of m minus 1 will actually call something like this. 5, look like in this case 5 plus foo of 5 minus 1, correct? Or rather 5 rather 4. Okay, and So this, when it is 4, so now it is 4. So now what is m changed to 4? Okay, so this is a recursive function. Now again this function calls foo, so it will now call m as a 4. Now when 4 is there, m is not equal to 0, so it will not return 0. So again it will call m minus 1. Now m minus 1 becomes 3. So now at next time m minus 1 equal to 3. So m will call it will 3. Now again it's still not equals to 0. So again it will call again foo. So f foo of 2 it will call, right? Next time 2 minus 1, it will call foo of 2, and it will again call foo of 1. When foo of 1 is called, again it is not equal to 0. So foo of m 1 minus 1. So now m is equal to 1. Now if I do m minus 1, so it will call 0. Now the function m is equal to 0. So foo 0 will return 0. Then next will be correct. Next it will return foo 0. Then we will again go foo 0 will return foo 1, which will be again 1. So 0. So I should write it somewhere. What all we are getting. So first we are getting, so as foo of 5 we are getting, first we have got 0 from foo of 0, then we are getting 1 from foo of 1. Now it will call foo of 2, so we'll get 3, correct. uh, 0 plus 1. So like that it will call one function. It will now return at the every function, and finally it will return 15. Okay? Finally it returned 15. Okay, so 15, how it returns? So this is how another, here I have done it like this. Okay. So at first m is equal to 4, so 5 plus foo of 5 minus 1. At the second step it will call 5 plus 4 plus m minus 1, that will be 2. Like that it will go. Okay, so the function is basically will be foo of 5 will be just like, first we will call 0, then foo of 1 will be 1, plus 2 plus 3 plus 4 plus 5. So like that it will call one time, it will call and it will return yeah. So it will return till n. So if you call foo n, it will return. If you call foo of n, it will return 0 plus 1 plus 2 plus 3 plus n, which is nothing but n into n plus into n plus 1 by 2. Is by simple mathematical progression can show that this turns to, and if you just for checking, this gives us it, correct. So and so terminates with non-negative, and so but now think that foo is equal to minus 1. So now if I call foo of minus 5, what will happen? So again if I debug it, so foo of minus 5 will call foo of minus 5 minus 1, that is minus 6. Now foo of minus 6 will call minus 6 minus 1. So what it will cause? It will cause basically, so I just can show you every time. 2 times. So m is equal to -6, -7, -8, -9. So if I, how many times if I go, it will basically run in an infinite loop because m will can never be 0. Correct? So I'll stop it here. So it will be an infinite. So foo function always cannot terminate at n equal to n plus 1, n into n plus 1 by 2. The function can only terminates for non-negative n at with foo of n to n into n plus 1 by 2. One, 16. So this is how the second function works. Okay, there is some message. Incoming. Yeah, n is a perpetual. Yes, please carry it out. Hina, what is the doubt? If you can message or give me a like message that or tell me. Hina ji.
Sir, non-negative is the answer, no, sir. Non-negative with
Yeah,
n
non-negative is the answer. Yeah, this one is the answer. Because if
yes,
it is a negative value, it will come into an infinite.
yes.
Okay, week 2 assignment I will do in the next week's class because this is for the first week 0 class. So the next week we'll check the week 2 assignments. Okay, week 2 assignments and week 2 code. And so yeah, this class was still now here only, and I won't. So this should be a short class. It was a short class, and I'm really sorry for the disruptions and everything. So someone has raised their hand. See, yeah. See, yes, raised their hand. Has raised their. Can we have recording? Yes, thus the YouTube session, YouTube recording will be there, so you can have the recording in the YouTube. Okay. Yeah, Priyanka Gupta. Yeah. So any doubt? Priyanka is not here. Okay. Then so for this week, this was so this much we have it. Yes, the class is done. You can, if you if you don't have any doubt, you can leave. So next week we'll solve the week 1 assignments and week 1 quiz. Uh, can you discuss Euclid's algorithm from the week 1 session? Okay. Let's see. This.
Actually, I have only one doubt in that.
Yeah.
We are considering the for GCD, we are considering the number n modulus of I. Sorry, it was something like we are doing m modulus of n, right? And then what we are getting the remainder, right?
Yes. We are getting the remainder.
So we are trying to find out the GCD of n and the remainder. So
Correct.
how
Correct.
are we coming under the conclusion that the GCD for m and n will be same as n and the remainder? How we are coming under that conclusion?
Okay. Let me
Mathematical.
open the video once. Sorry. Euclid recorder for GCD. See the screen. So
by solving a smaller problem and using that answer, in this case directly, to report the answer for our current problem. So we want to solve the GCD of M and N.
okay, so these are the Euclid algorithm.
Down from the minimum of M comma N to 1. So we kept checking whether I was greater than 0 and we kept decrementing. Well, here we are doing the recursion using a while. So the first thing to notice here is that I have...
Yeah. So this was, I think, the final Euclid algorithm. But it was here.
Let us see one problem with this by doing a hand execution. So supposing we start with some number 99 and okay, come down to GCD of 5 and 2, and this will get GCD of that.
Yeah, so here...
So this actually seems to be doing worse than our earlier algorithm in certain cases. So here is a better observation. So suppose n does not divide m. In other words, if I divide m by n, I will get a quotient and a remainder, right? So I can write m as q times n plus r, where q is the quotient and r is the remainder. So you may remember these terms from high school arithmetic. So this is n goes into m q times and leaves a remainder r, and we are guaranteed that r is smaller than n. Otherwise, it could go one more time. It will become q plus 1, right? So we have a remainder r which is smaller than n. So for example, if I say 7 and I want to do dividing, that we have a common, like before, we can write m itself as a times d and n as b times d for some numbers a and b, because m is a multiple of d and so is n. So if we plug this into the equation above here, right, then we see that m, which is a times d, is equal to q times n, which is b times d, plus r. So d divides the left and d divides one part of the right. Okay? So you can easily convince yourself that d must also divide r. Okay? So the way to think about it, if you want pictorially, is that I have this number m. Look at d box, it is going to stop exactly at this boundary because d also divides n. Therefore, d must also stop before with the difference. So last time we said we would look at the difference m divided by n. Now we are saying we look at the remainder of m divided by n.
So, hello. So I would ask the question. Who would ask the question? Can someone say? Yeah. Hello?
Yes.
Yeah, you
Yes.
have asked a question now. Okay. So what is your question? Like, what is the confusion here in the part?
There is no confusion in the programming. I just wanted to know the concept behind it. How we are coming under the conclusion that to find the GCD for M and N2 numbers, the GCD will be same to that what of the GCD that we will be finding of N and modulus or remainder of M and N.
Okay, I understand.
Mathematically, how we can consider that the GCD of N and remainder of M and N will be equals to the GCD of M and N.
Yeah, so as I can see in this, you can see in this particular here, this particular part. Yeah. So
And consider the GCD that divided, and as I'm going to stop.
So particularly here only I'm saying. So you are saying that so d is divisible by m and n is also divisible by d. Okay. So if you divide again the m and n, so this particular r parts, that will be m minus r part is basically the quotient, right? M plus q n
Yeah,
equal to r.
no, R part is the remainder, not the
Sorry,
quotient.
yeah, r part is the remainder. Yeah, correct. R part is the remainder, and so if you divide n by d and m by d, so since d divides both m and n,
Yes,
this small part is basically r, right?
yes, the remainder.
Yeah, so this also should be divisible by d, right?
D.
This r
Yeah.
should also be divisible by d, right?
Yes, yes.
Yes. Uh,
Exactly
so
at this
now,
boundary, because D also divides N.
yeah,
Therefore, D
so
must also divide this last bit, which is R.
huh.
Exactly. So, in other words, we can argue very easily that R must also be a multiple of D. So, D must divide R as well. Right? So,
D is dividing R, but
Correct.
how can we consider that N, if we find a GCD for N and R, it will be equals to the GCD for M and N?
Uh,
Mathematically or logically, how can we derive this thing?
okay, I think yeah. So if you okay,
so in other words, we can argue very easily that R must also be a multiple of D. So, D must divide R as well.
I understood your question. Yeah,
So,
yeah, that's
if
something
D
I should
divides
also check.
M and D divides
Yeah,
N,
this
there
is
is
a
a
tricky
remainder of
thing. I don't know
N.
how to derive it.
Yeah. I'll come back to you. So can you just give me your mail ID? I'll just note down your mail ID.
Should I ping it or speak on the chat? Speak
No,
it
you if you want, you can just ping me personally. That's not an issue.
personally.
Personally or in the chat, whatever you want.
Okay, let me ping it.
I'll get back to you with this. I think I also have some issue understanding this. Yeah, I'll get back to you.
I have pinged it just now.
Okay, Rahul Gupta 5 October. Yeah, I'll get back to you. Okay, on this.
Similar was for the previous solution also with the same Euclidean algorithm. They were subtracting it continuously with n,
Yeah,
and finally they were finding out the GCD, right?
correct.
Means similar is the question for that also.
Similar is the question for that also. Yeah, I understood. Yeah,
What is the logic? How they are deriving to this logic?
I'll get back to you with this, with
Yeah,
the
sure.
mathematical solution. Okay.
Yeah, okay.
Because I'm not a mathematics guy, so it's something.
Okay.
Yeah, I basically I'm a biology PhD, and I
You're a
do know.
biology PhD.
Yeah, I'm a biology PhD, but I as a Python I know as a Python. So I do lots of bioinformatics regarding during in my course PhD work.
Okay.
So so yeah, so mathematical thing I'll get back to you. I'll see and get back. Okay,
Yeah, sure.
sure.
Okay.
So that's why I was assigned, because I know more about Python rather than mathematics.
Okay.
So I do lots of bioinformatic work during my PhD. But yeah,
Okay.
okay. I'll get back to you. Thank you.
Thank you. Yeah, thank you.
Okay, thank you for joining, everyone. I'll stop the meeting here.
Yeah, sure.
Thank you, sir.